You've told that story 1,000 times. Now get me some cranberry juice. I'm parched.
I did not fart.
Doris, why do you invite your deaf friends over?
I'm not dead, you old bum. But I will be soon if you don't turn on this air.
The air is on and so is the fan.
Why don't we just open a window?
Be my guest.
Oh, that's much better.
Dr. Oz says this nice cool air is good for my arthritis.
You don't even have arthritis, Doris. And who cares about the temperature? I felt fine before. Temperature's just a number of them scientific people's made up.
Well, actually, temperature is a measure of how hot or cold something is. Specifically, a measure of the average kinetic energy of the particles in an object.
So if there's more kinetic energy in an object, the temperature is higher?
Yes, Doris.
Oh, like when I boil water.
You never boil anything, you old...
Shut up and let me talk. When I boil water for tea, the kinetic energy of the particles is greater than when the water is just warm or cold.
Those particles, they move faster than Mary Lou and her hover around.
And remember that there are 3 different measurements of temperature. For instance, on the Celsius scale, water boils at 100 degrees, the body temperature is 37 degrees, the room temperature is at 20 degrees, and water freezes at 0.
But I was taught that 32 degrees was the freezing point.
Shut up, you old hag! You don't even remember what you had for breakfast this morning. No, you don't know what you were taught in the dinosaur age.
Actually, you didn't even make breakfast this morning, so you can shut your big...
Now, Doris, Frank is right. On the Fahrenheit scale, water does freeze at 32. There's also a Kelvin scale, but I need to finish before my taxi comes to get me.
It's okay. That's covered on our window panes. Not exactly sure why.
But there's lots of other stuff to know.
Like what?
We can start with conduction.
Conduction?
Conduction. Imagine you just put a cold spoon in a pot of hot chicken noodle soup.
Can it be tomato?
Tomato soup will work. Soon the handle of the spoon will begin to warm up, even if it's not in the soup. That is because the spoon is a conductor.
So that's thermal conduction?
Yes, Doris, which means the transfer of thermal energy from one substance to another through direct contact.
But how does that work? What happens with the particles?
When 2 objects touch, these particles collide. Thermal energy is transferred from the high temperature object to the lower temperature object, thus warming the lower temperature object.
Oh, but that doesn't happen with everything, does it?
No, these are conductors and insulators. Insulators don't transfer thermal energy. One example is a flannel shirt.
Oh, I wear those. And oven mitts.
And ceramic bowls.
Good job. How about some conductors?
Still.
Good job. Now on to convection. Convection is the transfer of thermal energy by circulation or movement of liquid or gas.
You're like one of them encyclopedias.
It's an encyclopedia, stupid!
Well, I was top of my class back in the day. When you boil water, the heat from the stove causes the water to heat up. As the particles become less dense, the water begins moving swiftly in circles. The water near the top of the pot begins to cool.